Welcome to CognitionChunks. This information is for entertainment only. Note these backgrounds are artistic, not realistic. I am not an astronomer. Is this useful? Is this nonsense? Join me as I attempt to learn from GPT. Here is GPT Explains the Galaxies. Episode 11. Color Magnitude Diagrams and Galaxy Morphology. Color magnitude diagrams are powerful tools in astrophysics, providing insights into the stellar populations within galaxies and helping to decipher their evolutionary histories. By plotting the magnitude, brightness of stars against their color, temperature, CMDs reveal patterns that correspond to different stages of stellar evolution. When applied to entire galaxies, these diagrams can shed light on the galaxy's morphology, age distribution of its stars, and its overall evolutionary stage. Fundamentals of color magnitude diagrams. Magnitude. In CMDs, magnitude serves as a proxy for the luminosity or brightness of stars. The vertical axis typically represents absolute magnitude, which is a measure of a star's intrinsic brightness, as it would appear at a standard distance from Earth. Color. The color of a star, plotted on the horizontal axis, is indicative of its surface temperature, with bluer stars being hotter and redder stars being cooler. Color is often determined by comparing magnitudes in two different wavelength bands, for example BV, where B is blue light magnitude and V is visible light magnitude, serving as a simple measure of a star's spectral energy distribution. Main sequence. One of the most prominent features in a CMD is the main sequence, a diagonal band where stars spend the majority of their lifetimes fusing hydrogen into helium in their cores. The position of a star along the main sequence indicates its mass, temperature, and luminosity. Red giants and supergiants. Stars that have exhausted their core hydrogen fuel and have evolved off the main sequence appear in the CMD as red giants or supergiants, occupying the upper right region due to their cooler temperatures and higher luminosities. White dwarfs. These remnants of low-mass stars appear in the lower left corner of the CMD, characterized by their high temperatures but low luminosities due to their small size. CMDs and Galaxy Morphology. The collective CMD of a galaxy can provide insights into its morphology and the evolutionary processes at play. Elliptical galaxies. CMDs of elliptical galaxies typically show a dominant population of older, redder stars, clustering around the red giant branch and the red clump. The lack of significant main sequence population suggests a paucity of recent star formation, consistent with the observed properties of elliptical galaxies. Spiral galaxies. The CMDs of spiral galaxies display a broader range of stellar populations, from young, hot, main sequence stars to older red giants. The presence of substantial main sequence populations, particularly blue, young stars in the spiral arms, indicates ongoing star formation, reflecting the diverse stellar content of spiral galaxies. Irregular galaxies. Irregular galaxies often show CMDs with significant populations of young, blue stars, indicative of active and recent star formation. The spread of stars across the main sequence and the presence of luminous blue variables or supergiants can highlight regions of starburst activity. Lenticular galaxies. S0 CMDs of lenticular galaxies may resemble those of ellipticals with a red, older population, but can also show traces of younger stars in their disks, suggesting a more complex star formation history. Advanced CMD analysis. Modern astronomical surveys and deep photometric observations allow for the creation of detailed CMDs for galaxies beyond the local group. These CMDs, combined with spectral analysis and other data, enable the study of galaxy morphologies in the context of their stellar populations and evolutionary histories. Techniques such as synthetic CMD analysis, where observed CMDs are compared with models of stellar evolution, provide powerful means to infer the star formation histories, chemical enrichment, and dynamical evolution of galaxies. Conclusion. Color magnitude diagrams serve as a fundamental tool for understanding the stellar populations within galaxies, and by extension, the galaxy's morphologies and evolutionary stages. The distribution of stars within a CMD can reveal the ongoing and past processes of star formation, stellar evolution, and galactic dynamics, offering a window into the life cycles of galaxies across the universe. Thank you for joining us for another CognitionChunks. Please like and subscribe.